Module 8, Measures of Dispersion or Interval Estimates, Section 2, Variance and Standard Deviation. So sample variance is the average of the square of the deviations about the sample mean. So deviations about the sample mean will add up to 0, that we have seen that while discussing about the mean absolute deviation. So the way we calculate mean absolute deviation, it is quite similar. So instead of taking the absolute value, we are squaring it. So that is what it is known as the variance. So there are two variants here. One is called sample variance, while the other one is called population variance. Both have got different equations. For the sample variance, the denominator is n minus 1, while for the population variance it is n, just n. That is what take the average of it. But in the case of sample, it is n minus 1. So as I told you, sample is a subset of the population. So if you do it with the simulated data sets, so if you calculate the sample variation or sample standard deviation, then the value is always less than the true value. So that is why to increase that value, the denominator is minus with 1. That is why it is n minus 1 in the denominator of this one. So average of the square of the deviations about the sample mean. So you are squaring each deviations. So this denominator of this sample variance, that is n minus 1, is also known as degree of freedom, which is quite an interesting concept in statistics. So the degree of freedom is the number of independent values or quantities which can be assigned to a statistical distribution. So that is called the degrees of this freedom. For example, you can imagine that you have 7 shirts in your wardrobe. So 7 different colors of the shirt. So each day you have to wear a different color. So the first day you have 7 choices, second day you have got 6 choices. So it goes on like that. Then 6th day you will be having only 1 choice, and 7th day there won't be any choice at all. You have to wear whatever is the leftover. So the degree of freedom is only 6 if you have 7 shirts. So usually the degree of freedom is n minus 1. So n is the size, minus 1 is the degree of freedom. So that is why it is actually divided with n minus 1 in the case of sample variance. But in the case of population variance, denominator is just n. So it is taking, virtually you are taking the average of the squared values of the deviations about the sample mean in the case of the population variance. So population variance, the equation is sigma x minus x bar squared divided by n. So that is what the population variance is. So the variance, if you look at the shape of the variance, the graph, you will see that, so is it actually a highly varying or less variance, but just by looking at the histograms of different different distributions. So in this diagram you can see that there are 3 different distributions with entirely different mean or mode, but all of it has got the same variance because the shape is exactly same. So the shape parameter is what you call the variance of a data set, while in this case you can see that there are 3 distributions, each having same median and mode, but its variance is very different. So one is actually the peaked one is it is actually having a least variance, while it become platykurtic or flat shaped, then the variance become increased. So that is what it is, the variance. So the variance is extremely important. Can you actually draw in a river of the average depth of 26.9 centimeter? So probably you might think that 26.9 centimeter is nothing, but that is an average. You should see that. So in the river, so it could be just an average. So there might be some big depths in the river. So of course you can draw in that one. So that is why the variance is extremely important in statistics as well as in the real life. Let us calculate the variance with the same data set that we have been discussing, the blood sugar level. So we can continue this variance calculations from where we stopped in mean absolute deviation, because the calculation is almost identical. Let us restart from that same whiteboard. So we have seen that in the mean absolute deviations, so this is actually the mean of deviations about the sample mean. So the sample mean we have calculated 94. So each value subtracted with 94, and we are taking the absolute of this form, and then we calculate the mean of this value. So it's very identical, the calculation of variance is very identical. So instead of this step, from here what we are doing is that next column we can draw here, the next column. So this column is, instead of x minus x bar, the absolute one, we are just squaring it. So that is x minus x bar squared. So you are squaring these values to this column. So let us square it one by one. So the first one is 14. So once you square it is 196. Next is 576. Next is 1. Next is 36. And finally squaring 31 will become 961. So these are the squared values of this deviations about the sample mean. And now next step is to calculate the total of this one. So the total comes to be 1770. So this is the total of the deviations about the sample mean. So this is the first step here to calculate the variation of this data set. So next step is the degree of freedom. So what is the degree of freedom? So for the sake of brevity, let me erase this part. So the equation for calculation of the sample variance is that it is sigma x minus x bar squared divided by n minus 1. So n minus 1 is the degree of freedom. This is x minus x bar. So here x bar means the mean. So the mean is that we have already calculated, the mean was 94, and now n is 5. So let us plug into this equation. So sigma x minus x bar square. So x minus x bar square is this column, and sigma is just the summation. So it is 1770. So 1770 divided by n minus 1. So n had been 5. So 5 minus 1 is 4. So this value is going to be 442.5. So this value is what you call the sample variance. So the calculation is very similar to the calculation used for the mean absolute deviation, but the only difference here is that instead of taking the absolute scores, we are now taking the squared deviations. So squaring, the rationale for squaring is to get rid of the negative values, and then we are taking the average of it, but there is a slight change in the equation. So instead of simply taking the average, average means this value divided by n. So the denominator is n minus 1. As I already explained to you, n minus 1 is the degree of freedom. So 442.5 is the variance of this data set. Next is standard deviation. So standard deviation, if you know how to calculate variance, is very simple. Standard deviation is the square root of the variance. As I told you, there are two formulas for the calculation of variance. The first one is sample variance. So usually we work with the samples in biology or any other fields of the science. So usually the pertinent equation is n minus 1 and the denominator. So that n minus 1 I told you is the degree of freedom. So if you are working with the population, like if you are working with the class data, pedagogical data, or if you are working with the census data, then you are working with the whole population. So in that case, the variance, the formula, the denominator is n. So likewise for the standard deviation, there are two formulas. So the formulas are exactly same as the variance. There is absolutely no difference except that it's the square root of that formula. So the standard deviation is square root of variance. So that much you have to understand. So just calculate the variance and take the square root of it. Let us calculate the standard deviation of our earlier data set of the blood sugar levels. So let us do that on the board. So this is what we calculated for the sample variance. So as you know, this is the variance of the earlier data set, which is the sample variance. As you can see here, the denominator of the formula is n minus 1. Had it been the population variance, we use n instead of n minus 1. So this is the variance, and I have already told you the standard deviation is the square root of this value. So simply take the square root of this value. So that comes to be 21.04. This is the standard deviation of this data set. So the calculation of standard deviation is very simple. So the formula used is almost identical to the sample variance. So the sample variance is n minus 1 is the denominator. So just take the square root of this. This formula is the standard deviation. So it is actually SD. So another way to say this, the standard deviation is S square. So S square is also the standard deviation. Otherwise, you can also use the term sigma. So sigma is used for especially for the population standard deviation. So usually we don't work with the population. So let us stick with the S square or ST as the notation. So this formula is for the sample standard deviation. So had it been for the population standard deviation, the formula would have been square root of sigma x minus x bar whole square divided by n. So that is the only difference here between the two formulas. So it's exactly like the variance, you just take the square root of the variance to calculate the standard deviation. Remember that the standard deviation is always expressed plus or minus sign from the mean. So mean plus the standard deviation and mean minus standard deviation. So plus minus is always an error. So if you are plotting a graph, so let us say column graph, so the standard deviation will be the error bar. So plus and minus of that. So it's always with the mean, not with the median. So because the way the standard deviation is calculated, it's based on the mean. So it is mean plus or minus. Now let us see another data set. This data set is like almost identical to the earlier one, but it has got elements 10, that is the size of it. These are nothing but the blood cholesterol levels of the 10 individuals. So you can redo the same thing in a tabular way. I suggest you always stick with the tabular manner so that you can easily spot the mistake that you did it while calculating the variance, and the square root of the variance is nothing but the standard deviation. You should know that the standard deviation is always quantify the scatter in the data set. It's not about the precision, it's just the scatter or the variability of the individual points in the data set. So if your intention is not to plot the scatter, but to plot the precision of the way like mean, how good the mean, the estimate is comparing with the population mean, then the standard deviation is not a good estimate at all. You should go with SCM, or much better is 95% confidence interval, that I will discuss that later. So standard deviation is only about the scatter in the data set. So as you can see in this diagram, you can see that these are the column scatter graph. So the scatter, so you know how the points have been divided. So it is just within one standard deviation, you can see that majority of the values fall under the one standard deviation of the mean. Tell you the exact, is almost like 68% of the values will be fall within one standard deviation of the mean. So standard deviation from the non-Gaussian distribution again doesn't make sense, because standard deviation is a parametric statistics, it's not a non-parametric. So if your distribution is not normal, then there is no point in going for the standard deviation. So this is a common mistake that most of the students of the biology they do, not even biology but across the sciences, that they express that in standard deviation, but if the distribution is not actually coming from the normal or Gaussian distribution, for example, had the distribution been a log normal distribution, then going with the standard deviation makes really no sense. So in this particular diagram, you can see that there are actually 3 data set, each have got you know the same mean and same standard deviation, but you can see that only the first one is having the normal distribution, second one is absolutely a log normal distribution, while the third one is discontinuous distribution, you can see that. So in this case of log normal or discontinuous, the standard deviation makes no sense. Let us have a mini reflection point here. So calculate the standard deviation from if the mean is 12 and n is 24. Mean is 12, n is 24. How can you calculate the standard deviation? If you wish, you may pause the video right now and come back later. Well, as I told you, there is no way that you can calculate the standard deviation from the mean and n alone. So that is not a possibility, because unless you know the whole data set, so you have to get the raw data. So without raw data, it is not possible for anyone to calculate the standard deviation. So that is actually how the standard deviation is calculated. So there are several properties of the standard deviation. If a constant is added or subtracted to each of the observations, then standard deviation remains unchanged. So there is no problem with the standard deviation, it remains exactly same, because the scatter or the data variability remains unchanged by adding or subtracting. So if the observations are multiplied by a constant, then what will happen to standard deviation? Standard deviation also gets multiplied with the same constant. So that is what happens to the standard deviation if you multiply it. So standard deviation can be approximated by, if you know IQR, that is interquartile range. If you know IQR, then you can divide that with 1.35, that constant. If you divide IQR with 1.35, you will get an approximate value of standard deviation. So, as I told you, it's an only approximation. So, it works very well if the distribution is perfectly normal. So, as you know, majority of the empirical data set, it's not really perfectly normal. So, there are a lot of departure from the normality. So, this equation might not be always applicable. So, in many cases, it's also true that almost 68% of the whole observations fall within one standard deviation of mean, while 95% of the whole observations fall under the two standard deviations of the mean. So, this is what is known as central limit theorem. So, this theorem is extremely important in across the statistics. So, if you want to say that if you can extend it within 3 standard deviation of the mean, it is 98.6% of the observations will fall within 3 standard deviations of the mean. So, as you can see in this histogram, you can see that majority of the value, that is almost 68%, it is marked in the red, the dark color here, that is the black color here. So, the black values are 68% within the 1 standard deviation of the mean. So, as you see, the standard deviation is always plus or minus the mean. So, the mean is the middle value here. And then the dark blue color represent the rest. So, that is actually within 2 standard deviation of the mean, it is 95% of the data sets, and while within 3 standard deviation of the mean or 3 sigma, it is almost 98.6%. So, this is also known as empirical rule or 3 sigma rule of the statistics or central limit theorem of the statistics. Another thing that you should be very careful about is that there are 2 kinds of replicates in biology or across the sciences. One is called the technical replicates, while the other one is called the biological replicate. As you can see in this table, these tables are actually nothing but the lots of values of 3 different algal specimens. So, these are 3 different algal genus. So, genus is 1, while plural of the genus is genera. So, there are 3 genuses or genera in it. So, here it is Fucus, Gracilaria and Caulerpa. So, here the columns represent 3 biological data, while the rows represent 4 repeated measurements. So, this repeated measurement is nothing but technical replicate. So, you are measuring the cell size again and again, to see the variance or standard deviations of it. So, how can you calculate the standard deviation of this data set? Will you calculate the whole one, or will you simply divide it or partition it? So, if you calculate the whole one, then the problem is what you call as pseudo replicate. So, that is actually a wrong one. So, instead of doing that pseudo replication error, so you have to partition the data, you have to calculate individually by column wise, you have to do this. So, column is actually already grouped under the biological replicate. So, there is no point in combining one or more biological replicates to make it as a pseudo replicate. So, that is actually a wrong practice. So, you have to you have to calculate all these values, all these statistical measures in group wise. So, you should never combine these this one the group wise things. So, the standard deviation can be 0 if all values are identical, but it can never be negative. So, that is one of the properties of the standard deviation. It can never be negative, but it can be 0. So, standard deviation is expressed in the same unit as the data. So, the unit of standard deviation is exactly same. Standard deviation cannot be computed if the n is 1, but if it is n is 2, you can compute the standard deviation. So, standard deviation quantifies the variation within the population. So, it does not increase when the sample size is increased, or it does not decrease when the sample size is increased. So, standard deviation has nothing to do with the sample size, as you have seen that it is it's not really dependent upon the standards the sample size, but there will be a little bit or slight increase in the standard deviation when you increase the sample number. So, that is another peculiarity in statistics. So, if you increase the number to a very large extent, then there will be a slight increase in the standard deviation. But in the same case, when we are discussing about standard error of the mean or 95% CI, it tends to decrease when we increase the standard increase the sample size, but in the standard deviation case, that is not applicable. So, standard deviation can be computed even if the sample came from non-Gaussian distribution. However, the rule of thumb that 68% of all values lie within one standard deviation cannot be used in this case. And also it does not make sense, because standard deviation is a parametric statistical assessment method. So, parametry means that it depends upon the distribution from which the sample came from. The distribution dependent method, the parametric method. So, in summary, population variance is the average of the square of the deviations about the population mean. Sample variance is the average of the square of the deviations about the sample mean. Standard deviation is the square root of the variance. So, there are two formulas of the variance. Similarly, for the standard deviation also we have two formulas. Standard deviation quantifies the variability or the scatter of the elements, that is individual measurements of the data set. It does not decrease when the sample size is increased, unlike the p values or the confidence interval as discussed later. In normal distribution, it is true that approximately 68% of the whole observations fall within one standard deviation of the mean, while approximately 95% of the whole elements fall within two standard deviation of the mean. Biological replicates are different biological samples or species or organisms and so on, while technical replicates are repeated measurement to increase the precision in an experiment, right. So, that is then I discussed about the pseudo replicates as well. The data need to be carefully partitioned such a way to calculate the statistics separately for each biological replicates. Calculating overall statistic measurements makes no sense, a mistake often referred as pseudo replicate. Thank you. I hope you like this module.